Hi everyone, this is the last video for chapter 3 where we're talking about division and other bases. So just kind of like we've done everything else, we're going to do an example using a model and an example using an algorithm. So the example using a model is going to be using these base blocks. So first we're going to draw 3, 2, 2, base 5. So 3, 2, 2, base 5 is represented by 3 flats, 2 longs, and 2 units, okay? And we're going to divide this by 3 base 5. So one thing to note is that 3 base 5 is represents the exact same amount as 3 base 10, right? Because 3 is less than 5, these just represent the same amount, right? For example, 1O base 5 represents the amount 5 that we represent by the numeral 5 in base 10. So because we're dividing by 3, which has the same amount as the 3 that we know and love, this all is going to be a little bit easier. So we're going to start grouping things into 3s. So the first thing that we can group are the flats, right? This is a pretty easy group to see. We're grouping things by 3s, so we can see that we have a group of 3 flats. Okay, so we have one group of flats. And so now we see that the longs, we can't group at all. So since we can't group any of these longs, we are going to break them up. So we're going to take this long and this long and make them into 10 units, right? Because we're in base 5, each of these longs creates a group of 5 units. Okay, so we broke up those longs into 10 units. So now we group the units into 3s. So I'm going to start by grouping these down here. And then we can pull in these 2 from up here to get our last group. So now we've grouped our units. So now we just write down what we did. We write down the groups we have. So we have one group of flats, right? We have one group of 3 flats. Because we couldn't group the longs, we didn't have enough longs to group any of them into 3. So we ended up with 0 groups of longs. And then lastly, we ended up with 1, 2, 3, 4 groups of units. So we ended up with one group of flats, no longs, and 4 units. So that is going to tell us that 3, 2, 2, base 5 divided by 3 base 5 is 104 base 5. Okay, so that is our answer. So, like before, since we hadn't seen a model like this, I want us to go ahead and write down the steps of what we did. So what we did was we focused on, so we drew the number in base blocks, first of all. That's what we always do first when we deal with base blocks. We drew the number in base blocks. And then we started making groups of size 3. So I'm going to say identify because we don't really make them, we just point them out. So we identify groups of blocks of size 3. So I said it this way because we're not going to group a flat, a long, and a unit to get a size 3 group. We're going to identify groups of 3 flats, 3 longs, 3 units. Okay, so we identified groups of blocks of size 3, and then the last thing is, well, we regrouped, right? Since we couldn't make a group of size 3 for the longs, we did this step of regrouping if necessary. So we've seen this step before, where we regroup if it's necessary. And the last thing we did is count the groups. And then that gave us our answer. Okay, so these are the steps that we took. So now, instead of using base blocks and regrouping things, we're going to use an algorithm. So the algorithm that I am going to use here in base 5 is the traditional algorithm. So remember, the scaffold algorithm was one that dealt with estimation. But because we're dealing in bases, I think it's just easier to, do this using the traditional algorithm, no estimation, because I think that we're much more likely to make mistakes estimating in base 5, just because we don't live in a base 5 world and it's a little bit harder to get used to. So the first thing I'm actually going to do is write our base 5 addition tables and multiplication tables. So remember that addition and all of these operations are related, right? So we talked about how we can go from addition and take the inverse operation to get subtraction. And we can take addition as well and repeat it to get multiplication. So all of these things are really related. So I think having these tables, if you don't know them, is a really helpful way to just remember how to do things. So I don't think there's any shame at all in not knowing how. I'm sorry, that is not correct. I don't think there's any shame at all in not knowing how to write these things, right? There's no shame in not knowing these things off the top of your head. Oh man, already messed up. This is an addition table, not a multiplication table. My apologies. So I'm not going to talk to you while I write this because that's too confusing in my head. So I'm gonna write what I'm doing. Okay, so 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 2 is 4. 4 plus 1 is 1, 0. Okay, 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 1, 1. 2 plus 4. Oh, sorry, 2 plus 3 is not 1, 1. It's 1, 0. 2 plus 4 is 1, 1. Okay, well, I'm actually going to use our commutative property to fill in these values. That way I don't have to think about them a second time. 3 plus 3 is 1, 2. 3 plus 4 is 1, 3. And lastly, 4 plus 4. Oh, this is wrong again. I'm so sorry. 3 plus 3 is actually 1, 1. 3 plus 4 is 1, 2. And 4 plus 4 is 1, 3. Okay, so you can see that it kind of has this nice pattern, right? We have a diagonal that has all 1, 0, and 1, 1, and 1, 2, and 1, 3, right? You can see how it increases along the diagonals, which is a nice thing. Okay, so now I'm going to write a base 5 multiplication table. This is what I was doing in my head earlier, rather than the addition table. I'm not as used to writing addition tables as multiplication tables. Okay, so 1 times anything is 1. So that makes this first row, the first column, a lot easier to figure out. 2 times 2 is 4. 2 times 3 is 1, 1. 2 times 4 is 1, 3. We echo that down here. 3 times 3 is 1, 4. 3 times 4 is 2, 2. And 3 times 4 again is 2, 2. And 4 times 4 is 2, no, it's 3, 1. Okay, so we have these tables to help us do this. So now let's get to the actual division. So we're taking 3, 2, 1, and dividing by 3. So 3 goes into 3 one time, and we subtract 3 here, and we get 0, 2 left. I'm sorry, we're not doing 3, 2, 1. We're doing 3, 2, 2. But regardless, that doesn't change this first step. So we have that this. Now we're left with 2. 3 cannot go into 2. So just like we talked about, we need to put that 0 up here and now carry down 2. So now we're seeing how do we take 2 base 5 and divide by 3? So this is where having this multiplication table is really handy, because we see that 3 is a factor of 2, meaning that 2 is a multiple of 3, and it's exactly when we take 3 times 4. So 4 times 3 is exactly this 2. And this is how we divide evenly. So, right, so dealing with other bases, knowing that 3 times 4 is 2 is not nearly as obvious when you're not used to working in this base system. So I think it's just good to, especially just to get used to it, right? So you can see that the examples that we've done are mostly base 5 and base 8. So eventually you might have these addition and multiplication tables memorized a bit more. But for now, I think it's a good strategy just to go through and write them down before you do it. Or even make a formula sheet for yourself. Write it down. Have it on a paper where you reference it whenever you do problems like this. Okay, so that is all for division whole numbers. That's all for chapter 3. That's all for the content before the first exam. So we made it through, and that's all for this video.